Today is the day 7. Today is the day 7 of the transformer. So let us see the winding on separate limbs. When high voltage winding and low voltage windings are placed on the separate limb of the core, the current in both the windings flow in the same direction. This is necessary to satisfy the transformer action. Leakage flux is higher because the windings are physically apart. Leakage flux is higher because the windings are physically apart. Windings on the same limb with interleaving. When high voltage and low voltage windings are placed on the same limb with interleaving, current in high voltage and low voltage winding flow in the opposite direction. This improves the mutual flux and leakage flux is reduced and coupling improves. Effect of the interleaved and sandwiched winding. Let actual transformer leakage flux be psi and phi with interleaved winding leakage flux is equal to phi by 2. With sandwiched winding, leakage flux becomes the 5 by 4. Hence, sandwiched winding gives the minimum leakage flux. Winding placement in shell type transformer. In a shell type transformer, windings are placed on the middle limb. Winding placed in the shell type transformer. In a shell type transformer, windings are placed on the middle limb. Each winding, that is HV and LV winding, is divided into the several sections. These sections are placed alternately HV, LV, HV, LV. This arrangement is called as a sandwiched winding. Purpose of using the sandwiched winding: to reduce the magnetic leakage flux, to improve the coefficient of coupling between the HV and ELV winding, to improve the overall transformer efficiency. Symmetrical and asymmetrical distribution of winding. Asymmetrical distribution: windings are not evenly distributed, causes mechanical imbalance, higher leakage flux and electromagnetic forces. Higher leakage flux and electromagnetic forces. Symmetrical distribution: windings are uniformly distributed, provide better mechanical stability, leakage flux is minimum. Symmetrical distribution: windings are uniformly distributed. Symmetrical distribution: windings are uniformly distributed, provide better mechanical stability, leakage flux is minimum. Low voltage winding rule in shell type transformer. In shell type transformer, extreme LV winding section should have 50% more turns than the inner LV winding sections. This ensures symmetrical distribution. What is the use of asymmetrical distribution? How is the asymmetrical distribution? Windings are not evenly distributed, causes mechanical imbalance and higher leakage flux and electromagnetic forces. Symmetrical distribution: windings are uniformly distributed, provide better mechanical stability, leakage flux is minimum. LV winding rule in shell type transformer. In shell type transformer, extreme LV winding section should have 50% more turns than the inner LV winding sections. This ensures symmetrical distribution, improves mechanical strength of the winding. LV winding rule in shell type transformer. In shell type transformer, extreme LV winding section should have 50% more turn than the inner LV winding sections. This ensures symmetrical distribution, improves mechanical strength of the winding. Forces in shell type transformer. Under normal operating condition, only axial forces act on the winding. Under abnormal condition, short circuit faults, both axial and radial forces act on the winding. Forces in shell type transformer. Under normal operating conditions, only axial forces act on the winding. Under abnormal condition, Both axial and radial forces act on the winding. What are the key points to remember? Interleaving. Interleaving. In interleaving, leakage flux is 5 by 2. In sandwiched winding, leakage flux is 5 by 4. Means sandwiched winding is more better than interleaved winding. In shell type transformer, middle limb plus sandwiched winding, symmetrical distribution, better mechanical stability. Due to the symmetrical distribution, better mechanical stability.